Hi everyone, in today's lesson we're going to talk more about that limit definition of the derivative, but this time with radicals. So, example, using the limit definition of the derivative, find the derivative of f of x equals radical x plus 2. So we always start by writing the formula. F prime of x is my derivative, which is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, we're going to be as neat as possible. So f of x plus h means everywhere I see an x, I'm going to put an x plus h. So I'm going to set it up like I did in the other video, where I have f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to say the yellow is your f of x plus h. The green is your f of x. Remembering that f of x is always your original function. So we can go ahead and put that in here. My original is x plus 2. And my f of x plus h is substituting x plus h everywhere I see an x. So if I do that over here, just means for this x, I'm putting x plus h and then plus 2. So that can go here. X plus h plus 2. So now, if we did direct substitution and we plugged in h as 0, we would get 0 over 0, and that wouldn't work. So we have to think a way out of this. So you've already done this before with numbers and radicals. You have to use conjugates. So I'm just going to rewrite this so that we have room to simplify. So we have the limit as h approaches 0 of rad x plus h plus 2 minus rad x plus 2 all over h. So conjugates. The conjugate of this numerator is switching the middle sign. So x plus h plus 2 plus rad x plus 2. And whatever I do to the bottom, I have to do to the top. And just like we did with the limits, we're going to double distribute the conjugate pair. So double distribute, and we're going to leave the other part alone. So let's do our double distributing. So this one times this one, any radical times itself is the same, or the inside rather. So x plus h plus 2. Now, this times this will cancel with this times this, so I'm not going to write it. And then I just have to do this times this. So any radical times itself is itself, so x plus 2. But we have to remember that we're doing a negative times a positive, so it's a negative, but it's a negative of all of this. So we actually are going to have to distribute that negative. So you can't just write minus x plus 2 because you're going to have to distribute. So just to recap, x plus 2, radical x plus 2 times radical x plus 2 is x plus 2, but a negative times a positive is a negative. So again, we'll have to distribute. And we'll leave our denominator the same. So h times x plus h plus 2 plus rad x plus 2. And we're going to keep following down our derivative as the limit as h approaches 0. So let's distribute this negative 1 and simplify. So we've got our derivative, f prime of x, as the limit as h approaches 0 of x plus h plus 2. Now if I distribute minus x minus 2 all over h times rad x plus h plus 2 plus rad x plus 2. So let's simplify our numerator. Looks like these 2's will cancel, looks like these x's will cancel, and we're just left with h over this. So I'm just going to simplify that further. I can cancel these h's out, but since nothing's left on top, we have to make sure we have a 1. So our derivative, our f prime of x, is the limit as h approaches 0 of 1 over rad x plus h plus 2 plus rad x plus 2. So now that we've simplified and got rid of our h's, we now can substitute using direct substitution. So everywhere I see an h, I'm going to put a 0. So my f prime of x is equal to 1 over rad x plus 0 plus 2 plus rad x plus 2. And I'm going to keep going. 1 over 0 plus anything is that thing, so x plus 2 plus rad x plus 2. And when we add radicals that are the same, we just make it 2 radical x plus 2's. So this is my derivative equation. And this will allow us to find the slope of the tangent line at any x value. So let's read part 2. Part 2 says, find the slope of the tangent line at x equals 6. So if we have our derivative, f prime of x, which is 1 over 2 times rad x plus 2, if I want to find the slope of the tangent line, all I'm going to do is plug 6 into my derivative. So 1 over 2 rad 6 for x plus 2. So I'm going to get 1 over 2 radical 8. Now, technically, you're not allowed to have radicals in the bottom of a fraction. Technically, you should be simplifying this 8, but we're going to leave it like this for now. So f prime of 6 is 1 over 2 rad 8. So what you just found is the slope of the tangent line at x equals 6. All right, that's enough for today. If you have any questions, now is a good time to jot them down, and we will see you in class tomorrow. Have a good night.